MacMillan Space Centre with another edition of Ask an Astronomer. I am here in my office on the beautiful day here in the unceded territory of the Musqueam, Squamish, and the Tsleil-Waututh. Also in her office, just a few doors down from me, is our astronomer, Marley. Hey, Marley, how's it going?
Hi, Michael. It's good. Glad I am not by myself this week. It's very stressful.
I see we finally got to see that Apollo rocket behind you. We have been teasing that for many weeks now. We finally get to see it in person. How long did it take you to make that Apollo Lego rocket?
Well, I think it came as 5 separate parts because it detaches actually into each component that the rocket launches in, like the main engine falls off. Anyways, I think I built it over in a week or so, but I also did not have much to do. It was when I had first moved to Vancouver and I was still quarantining from the office. So on my day, and like my lunch break, I would just build it. And I do that here now with the other Legos I have. On my lunch break, I'll build that.
Amazing. Well, Marley, we've got some stories to get to today. Of course, for our big story today, we're going to be asking the question, what's going on with the sun? But before we get to that, in a couple days, it's Christmas. If nobody has figured that out yet, Christmas is significant for a couple of reasons. It is Isaac Newton's birthday, but at 4 a.m., I don't know what you're doing at 4 a.m. on Christmas Day, Marley, but it is a pretty significant day for astronomers because the James Webb Space Telescope is set to launch. Give us an update. What is going on with our favorite telescope that loves to be delayed?
Yes. So if you were to type into your search bar space news, the top 4 results would be something like this. It's all about Webb. It's supposed to launch on Christmas morning very early, but some astronomers are still a bit skeptical because it was to launch on December 24th, actually, and then it got delayed again, which is why we have memes like this telling Webb that you go when you're ready because delays. But it's been confirmed that it should be launching on Christmas morning at 4:20 a.m. Pacific time is the earliest it could launch, and that window closes at 4:52 Pacific time. Wow. The same morning. So very early in the morning, very quick. But where we are in our timeline is we're actually T-minus a day and a bit, but the Ariane 5 rocket has rolled out onto its launch pad. So it is waiting to be fueled and any last minute, what they call aliveness checks to be done on the telescope. So there is the picture of it all ready to go, waiting to be fueled up and just sitting out on its launch pad waiting to start. And the thing with this rocket, when I first saw it, I was like, oh, it looks like a little small. It's 53 meters high. So everything in this picture is just very big, including the rocket. So it still has to be fueled. That'll start early tomorrow morning. They will start fueling the rocket and it'll be fueled with liquid oxygen and liquid hydrogen are its propellants. And the final electrical and software checks happen on the launch pad. As for the telescope, it'll switch to internal battery power about 20 minutes before liftoff. And within the last 15 minutes before liftoff, the launch vehicle will be fully cleared for flight. So they will check everything. And then within the 15-minute mark is when all the checks have to be done. And then they start the countdown really until launch. Though it can be waived or what's called like a pause if the weather is iffy. That happened, I think, with one of the Blue Origin flights. They did like a pause because the weather was not great. They're waiting for something to clear. So that still can happen. But as far as we know, it is go for launch at 4:20 a.m. on Christmas morning.
Well, it's just like, getting up early for Christmas. I don't know if that you were one of those kids that got up super early before your parents to open up your gifts. But this is what James Webb Telescope wants to do as well, right?
Well, it's a pretty interesting gift because it's just rocket launches are always stressful, regardless what's on it, it's always, well, at least for me, it's stressful regardless what's on it, but especially something like Webb, that's very expensive and has taken a long time to get here and kind of so much work went into it. I just want it to work so badly on the first go, which it will hopefully, but it's still stressful.
Yeah, so if you have any questions about the James Webb Space Telescope, you can put them into the chat. We've been talking about James Webb, it seems like for almost 2 months now. You can go back and look at some previous videos that we've done about it. I've got some more questions. I've been getting lots of inquiries, from the public. And of course, you were talking about this short window of time, because I was always very curious, why does it have to be so early? And why is it only this half-hour window at 4:20 a.m.? Why is there only such a short window of time that James Webb can go up?
It has to do with where Webb is going. So it's going to that point, the L2 point, which is just 4 times past the distance of the moon, so quite far out. But because of that, there are lots of different things going into this launch specifically that they have to make out for. Webb will make, I think, 3 what are called mid-course corrections, which means that it will have to change its trajectory ever so slightly 3 times. And because of that, they have to have a certain amount of fuel on board. And it's like a ton of math and lots of different things that go into it. There's also a specific type of orbit they want for Webb to have once it reaches the L2 point. And so there are only so many configurations where they get the optimal orbit that fits all of the different constraints they have. So some of the constraints are like the ability to communicate with the telescope. There's a certain distance, it can be a maximum distance that puts a threshold on it, the amount of fuel that's on board, which has to do with the amount of course corrections they have to take, where the sun, the earth, and the moon are as well. The gravitational impacts of all of those things will impact how much fuel Webb has to spend to do its course corrections. I also have to make sure that the angle between the sun and Webb during its flight to L2 does not cause overheating of the telescope. It's very, very sensitive to heat, and its heat shield deploys in stages as well. So they can't overheat any of the instruments on board. They have to avoid approaching the moon during the flight, which would avoid complications of correcting for the moon's gravity, which is why they can't really launch all the time, depending on where the moon is as well, because they don't have enough fuel to correct for it. They can't go into eclipses of the moon and the earth as well. They can't go into the shadow for the flight and for the entire mission, so that the solar arrays are able to constantly produce electricity, because that's how it gets its power. They can't have orbits around L2 with really large distances from the sun, which makes too much of an angle between everything, communications wise and data wise. And we have to make sure that the telescope's never completely illuminated by the glow of the earth or moonlight. And the communication has to be at what's called an effective angle for communication. So we always have a good direct line to Webb. So all of those constraints come into play, and there's more that go into the launch window. And what it boils down to is that there's 210 days a year where Webb can launch, has windows that could launch. The duration varies. Some of the windows launch up to 90 minutes, but just right now the windows are about 30 minutes. And all of them that have like the best probability of success always happen between mid to late morning local time in French Guiana, which is just very early morning for us just because of time zones. So it's all of these things come into play that prevent Webb from launching like in the middle of the day. They have to be careful of literally everything going on with the telescope.
Wow, so many different variables to think about. And of course, that L2 point, the Lagrange point, it's almost like a basketball that you're trying to shoot, but you have to release the ball ahead of time at the exact moment, and then sort of wait for this L2 point for the ball just to float in, and then it's just going to sit there, and that's where James Webb is going to live. Such an interesting and cool place to go, because once you get there, it's just going to stay there, right?
It's going to stay there. It's not going to be directly in the point. It's going to orbit the point. And so it'll have enough fuel to keep itself from like drifting off, but it'll stay in an orbit around the Lagrange point. And the Lagrange point 2 is like unstable, but not like unstable that it's just going to move suddenly, more so that it just kind of rocks back and forth. And so Webb also has to account for that. And I think that movement is about every 21 days. Webb will have to slightly shift itself to stay in the proper orbit.
Okay, so lots to look forward to with JWST. I know that everyone's going to be getting up bright and early on Christmas Day to watch the launch. Marley's got those links there. You can watch on NASA Live. But let's get to our main big story today and answer this question. What is going on with the sun? Of course, a couple of days ago, we had Solstice, and we are getting close to perihelion. So from our perspective, the sun seems to be doing some interesting things. But we also have some news on what's actually going on with the sun, with a spacecraft that has flown closer than any other human-made spacecraft has been made before. What is going on with the sun, Marley?
Right. So Solstice is just like a fun little quirk of orbits and the way the Earth is. And so the sun's path at winter solstice, that's the day we get the least sunlight, right? So the sun's very, very low in the sky all day, really kind of a bummer for me personally, because I love the sunshine and I'm like not in it, even though it's cloudy here anyways. So it gets we have the longest night on solstice, right? And during the summer solstice, when we have the longest day. So it's just where the Earth is in its orbit with its tilt and everything gives us these fun little quirks of orbital dynamics is the little fun thing. Perihelion is coming up. That's not till January 3rd. And perihelion is another quirk of Earth's orbit. So Earth's orbit is elliptical. It's not a perfect circle, not as exaggerated as I have it in my little handy man-made diagram. But because it's an ellipse, it actually has a part in its orbit where it is closer to the sun than otherwise is. And that part where it's closest is perihelion. And the part where it's furthest away is, I can never pronounce the word, aphelion. It's furthest away from the sun. So perihelion is on January 3rd, I think at 10:52 p.m. We will be as closest as we will get to the sun, and then we will start to move out of it.
But of course, unlike solstices, the perihelion and aphelion points don't really affect temperature that much. Is that correct?
No, like it's very heavily exaggerated in this diagram, but we'll start quite a ways away. Like we may be close to the sun, but we're also tilted, right? So we are, there's lots of things at play. It doesn't really affect temperature. We're not gonna all of a sudden get really hot at exactly 10:52 on January 3rd. It'll be, we'll be okay.
Right. Well, this is a special point, of course, in our orbit. And for astronomers, we like to call this the Astronomer's New Year. So we will be doing an event on January 3rd. You can get tickets on our website, spacecenter.ca. Marley and I are going to go over the top stories for 2022, the top space stories. And we're going to have a big game of Kahoot and give away some prizes as well. So hopefully you can join us then on January 3rd. We're going to have it in the evening time, last day of the winter break as well. Now, let's get some information. We can see that our sun is changing from our perspective, but we have a spacecraft that is flowing really close. What is actually going on with the sun, Marley?
Right. So what's actually going on in the sun, we have to go back to the Parker Solar Probe, which is a very exciting probe that doesn't get a lot of news, mainly because its camera is like not as great as other cameras that they have. And also because people aren't as excited about the sun. But despite it being like our star that provides literally everything for us, like heat, light, all of that stuff, we don't really understand it very well. And so Parker Solar Probe was going to go help understand the sun, specifically the part of the sun that is the corona. So this is just a little diagram that talks about Parker, and what it's actually doing is it is actually kind of flying into the sun's atmosphere and studying it, because we don't understand it really at all. So when we look at the sun, this is just a diagram of the sun and a picture of Parker. And normally when we look at objects that are hot, or even like Earth, for example, the further in you go, the hotter it gets. So when you're very close to the center, it's very hot. And as you move out, it starts to cool off. And this is true of the sun as well. As you go from the surface of the sun and move out, it starts to get cooler. But when you hit the corona, it all of a sudden gets super hot. And we don't know why, and it's not really expected. And so we're trying to understand why that happens. Additionally, the Parker Solar Probe is trying to understand the solar wind. So what the solar wind is, we know it more so as oh, the solar wind hits Earth, it interacts with our magnetosphere, and we get the northern and southern lights with those highly energized particles from the sun interacting with the particles in our atmosphere. But what we don't understand is where the corona ends and the solar wind starts. So on the diagram of the sun, the corona is like the very outer layer of the atmosphere. And the solar wind is kind of everything in between the corona and once it hits Earth. But where that line is, we don't know where that ends and where the solar wind begins. So it's called the Alvin critical surface. And what that line represents is where gravity and the magnetic fields of the sun are too weak to hold the sun's atmosphere in anymore. So the sun's atmosphere, just like Earth's atmosphere, is like gravitationally bound and bound by magnetic fields to stay around the sun. That's the corona. But at some point, it stops being bound. It's too weak to hold up against like the heat and the pressure of the sun pushing on it, and it drifts away. And to find that, they have Parker's solar probe kind of dipping into the corona itself, now that we know. So that was the big news with Parker, is that Parker touched the sun in the sense that it dipped into its corona. And we know it dips into the corona and wasn't just in the solar wind, because the data they got back indicated it had crossed this boundary. So there was suddenly a lot more magnetic field activity and magnetic consequences, as well as an increase in some of the gravitational effects that you would see. And that point happened at about 18.8 solar radii, which is just 18 or like 19 times the radius of the sun, how far away they were. So it really dipped. I think it was like 91% of the way from Earth to the sun is where that happened. So very exciting that it dipped in, and kind of confirms where we've assumed that point would be. Our basis for where we think that line would be was between 10 and 20 solar radii. And Parker, in its dips into the sun, or it's actually called this perihelion when this happens, because it gets the closest to the sun that it'll get, has been consistently below 20 solar radii. So we really can say that, okay, we are within the right range, and our math and our assumptions were pretty close, if not right. So very exciting.
Yeah, interesting. So Parker Solar Probe launched several years ago now. So what is the course of its mission? It seems to be doing these orbits around the sun. It's also going around Venus. How much longer of a mission is Parker Solar Probe on?
I think Parker Solar Probe is said to last, I think it's 2025 or 2023, but it may be extended, as often happens. Like missions are given like a set amount of time that they'll be like Webb is supposed to last 5 years, or in the case, I guess Hubble was only supposed to last 15, and now Hubble's missions has been extended. It's going on 31 years now, right? So the whole mission for Parker may change as it's going, but its scheduled mission end is for 2025. Is the last perihelion will be June 19th, 2025. And then I think its mission end is it's just going to launch itself into the sun, is how it's going to end. Similar to like Cassini, when they just like launched it at Saturn and they were like, good luck. But still sent back data the entire time. So yeah, Parker didn't launch until 2018. And it's been taking data, doing flybys and perihelions of the sun, and also Venus ever since.
Have we ever sent anything directly into the sun before? Is this going to be a first-time mission, sending a probe right into the sun?
No, I think we have. I think it's something that does happen. It's like an effective way to get rid of space junk, I think. It's just like send it into the sun. But I'm pretty sure there have been missions that have mission ended into the sun. I just don't know them by name.
And this is also what happened in Superman 4, when Superman gathered up all of the nuclear bombs that were on Earth and then flung them all into the sun to get rid of them. Unfortunately, that also created a new supervillain that was powered by the sun. But those were sort of the consequences. Hopefully that doesn't happen when Parker goes into the sun. No,
Parker's very, very small compared to everything going on with the sun. Very little, but still takes a huge amount of data. But it sent back some really, despite its camera not being like what people expect from a camera going to space, it's still taken back like super awesome images from this. So these images are from Encounter 9, and we can see what are called coronal streamers. And so those are the things that the little wispy bits that you see during a solar eclipse, a total solar eclipse, is those little wisps that you see. It actually flew like into them. And they are the bright features moving up and down in the images. So like here is like the streamers are here, there's one here, here, and then in the lower image are the ones like moving downwards here. So it's only possible to be able to see the streamers because Parker flew above and below the streamers while inside of the corona. And we've only, up until this point, seen them from far away during an eclipse, which is very cool. It also found out that the surface of the sun, like where they've decided past the Alvin line isn't the shape they thought it would. They thought it would be like shaped like a ball and very smooth, but it's actually quite lumpy for some reason. So with every answer we get, of course, we always get about 100 more questions. So that's just another one of the many, many questions that Parker has given us with its little trip to the sun here.
Yeah, this is very cool. This is pretty much some of the best pictures. And there is even a video as well that Parker's been able to take. Of course, it is very hard to take interesting photos and videos, but this video, which if it plays, is one of the coolest ones that I've seen from Parker.
It's very awesome. Here it goes. So that it just always needs a minute. It is the video of Parker. It's a collection of images like stacked, like put together. And it shows so many cool things happening from this video. If I rewind it and play it. So it's in the corona, and you actually see the planets, the Milky Way, there it goes, and more planets as it flies through the sun. It's so cool. So that's Jupiter and Earth. Jupiter's on the left, from left to right. That's Jupiter and Earth.
Oh, that's so cool.
Yeah, it's so awesome. And like all the video, like in the beginning, it was Venus, Mercury, Mars. And then you had the Milky Way and Venus. So Mars is the tiny little dot.
Yeah.
And then Venus is very bright. And then finally, if I was going right to left near the beginning of the image or the video Mars is a little tiny dot, then Mercury, then Venus is how that one goes. And then you have the Milky Way and Venus, and then you have
Jupiter and Saturn.
Jupiter from left to right, Jupiter, Earth, and then Saturn's a little tiny dot. Saturn's very, very dim. Yeah. Very awesome.
This is so cool. And we can see this tonight. I mean, of course, we see the sun all the time. Mercury, Venus, Jupiter, and Saturn are all visible. I'm just looking outside right now here in the lower mainland. Might not be able to see the sky tonight, but over the next couple of nights, if you haven't seen it, Venus super bright after sunset, as well as Jupiter and Saturn up there as well. And just seeing this view, from a different perspective, kind of like from the sun looking back to us, is a very cool perspective.
I don't know, it's so interesting. And I keep rewinding every time I watch it to see the part with the Milky Way, because I'm like, I've never seen that before. There's astronomers on Twitter thinking that perhaps that's the galactic bulge it's looking towards, which is like different from what we see, but it's just neat. But a fun thing about this video is that it's in the sun. And so the heat shields that Parker has, the max temperature was 1,377 degrees Celsius, but its payload, like where this camera is and where all the science instruments are, we're just at room temperature. So those heat shields were doing like the best job ever at keeping things from overheating. So good job to the Parker team for these videos, and the fact that the little thing didn't melt when it dove in. So.
Yeah, well, the heat shields, of course, play a big part. And of course, you even talked about the heat shields that are on the James Webb Space Telescope. They must play a big part for any space mission that's going out there, right?
Yeah, they do. Like, especially you see it a lot in like rocket launches, even like leaving and entering the atmosphere, having to have a heat shield. The Perseverance landing, it was encapsulated in a heat shield because as it enters the atmosphere, that generates heat. So heat shields are like very, very important. It's just these ones must be really robust to withstand the heat of the sun when being like right in it. It's just amazing. Very cool.
Awesome. Well, we've got a few more minutes. If anyone out there on YouTube land has a question about any of the stuff that we've talked about, James Webb Space Telescope launching in a couple of days, Parker Solar Probe still going around the sun, still going to be going around for a few more years. Drop them into the chat. So Parker Solar Probe is going around. You talked about some of its main missions. What are some of the other things that Parker Solar Probe is hoping to figure out?
It's also looked at Venus a bit, but that's not like its main focus. Its main focus really is just looking at the sun. But it's also really it's all studying heliophysics, right? Like the physics of the sun and how it works and what is kind of happening with it entirely. The mission, I don't really know how better to explain it than that. It's just like, let's just take a really good look at the sun. But its science objectives are a lot of like, how does the energy work? Like in the sun, like how is it heated and how is it sent off as well? Because all that energy like reaches Earth at some point. So how does that work? What causes the solar wind to move the way it does? And when does it start? And which they kind of figured out, but not really the mechanisms behind it. As well as why is the corona so much hotter than we thought it should be, right? Because it's the furthest thing out from the sun. It's the last part of the atmosphere, but it's still, it's hotter than the parts below it. Which they don't understand. So a lot of really that has to do with the energy of the sun and the mechanisms behind it and how it works are their main scientific objectives.
Cool. And the other thing that I do know about this Parker Solar Probe is that as it's going around the sun, and it's made a couple orbits already, it keeps going faster and faster because of those slingshot motions. And I believe it's been breaking some records, right, for fastest spacecraft?
It's hurtling. Like in that video that I played, I think at that one, its fastest point on that flyby, it was going 700,000 kilometers an hour. So it just whips around like so fast. But they get like months worth of data because the sun is so big, right? So it's going so quickly, but it's still covering a lot of space. It's hard to imagine actually, because I don't think I can properly conceptualize how big the sun is compared to this probe. But it speeds up, and then when it goes past Venus, it actually slows down a bit, and then it speeds up again.
Really cool. And just to drop our final space science fiction reference, this is exactly what happened in Star Trek 4 as well, when they went back in time. But Parker Solar Probe is not going to go back to the 1980s like the Starship Enterprise did in Star Trek 4.
No, it will not. It'll stay here.
Well, Marley, thank you so much for giving us an update on what's going on with the sun. This is our last Ask an Astronomer of 2021. I hope everyone out there in YouTube land has a safe and wonderful holiday. We will be back online for our perihelion event. Encourage you to join us there. We're going to have a lot of fun. We're going to play some trivia, Kahoot. We're going to go over all the top stories. If you have some stories that you want us to cover, you can send us a message and we'll cover them in our perihelion event. And we also have a cosmic night coming up that's going to be a hybrid event that's going to be partially in person and partially online, all about the Lunar Gateway. We're still looking for a speaker for that one, so TBD on our special guest speaker, but go to our website, spacecenter.ca. That is going to be on January 20th. That is going to be our next hybrid event that we're going to do online as well here in person. All right, folks, from everyone here at the H.R. MacMillan Space Center, have a wonderful holiday, have a wonderful end of 2021, and we'll see you in 2022.
Bye, everybody.